How's it going?
Good. How are you doing?
Not too bad.
So we're going to do 30 minutes on covering the problems you missed on your last quiz.
Um, I don't have that quiz back, but yeah, I guess somehow.
Okay. So are you going to
I think,
verbalize them to me or?
um, I think I understood the elimination and substitution. That was pretty easy.
Okay.
It was just like the different kind of graphing, like when you're graphing with like greater than or equals to, and then when you like switch back to like just graphing like two equations and like stuff like that.
Okay.
So could we just do like do you know a couple of those problems?
I can make some up.
Okay.
All right. Let's talk about the difference between graphing that and graphing that. Let's make things a little easier. Make this number 6. How would you graph the first equation?
Um,
Whatever
you would.
method you want. How would you graph that if I gave that first equation to you?
I'd go up 3 and then put a dot. Wait, I have to solve that first, don't I?
You don't have to. That's one way to do it. You can solve it for y and then graph it once it's in slope-intercept format. But this is in a format where it's actually a little easier to graph by just graphing the x and the y intercepts and connecting the two lines.
Okay.
What's the x-intercept?
3.
No, x-intercept means what about y?
Where it's gonna touch on the like x-axis.
No, what it means y is 0, right? If I'm
Yeah.
on the x-axis, well, that's y. That's y. If I'm somewhere on the x-axis, y is 0 in all three of those spots. So an x-intercept, by definition, means that its y is 0. So how do we solve for the x-intercept
You.
in that equation? You make y equal to 0 and then solve the equation.
Alright, so it'd be just 3x equals 6.
Okay, so what's the x-intercept?
3. Or. Uh.
If 3x equals 6, what does x equal?
2.
Alright, that's the x-intercept. That means the curve goes through that point right there. Real easy to come up with the x-intercept. Where's the y-intercept?
Does it just stay 2?
No. The y-intercept means what about x?
That x is 0.
Okay, so plug in 0 for x and solve the remaining equation.
3.
Okay, so I know one point on my curve is there, I know another point is there, I connect them, I'm able to graph that without knowing the slope.
Okay.
Okay, so to me, when you're given an equation in standard format, the easiest way to graph it is not to manipulate it so that I get y equals minus 3 halves x plus 3. In other words, if I take that equation and solve it, I get this.
Okay.
So now, if I gave you this equation, you would go up to 3, you would start there, you would use the slope, you would go down 3 and over 2. So you would end up with the same line. But what's easier to do?
First one.
Yeah, by a lot. In other words, there's no need to put it in slope-intercept format if you don't have to. but it's always good to know that that's just a different format than this. This is standard, this is slope-intercept. There's also point-slope. I don't know if you've learned point-slope or not, but there's lots of formats. All right. Now, let's talk about the lower one. Okay?
All right.
So this one is not an equation. It's an inequality. So first of all, it changes my line. It's either a solid line or a dotted line. The fact that it's greater than only means that it's got to be a dotted.
Oh, really?
Yeah, if it's greater than or equal, then it's solid.
What if it was less than? Would it still be dotted?
Yes. Anything anything that has strictly a greater than or less than is always dotted. Anything that has greater than or equal or less than and equal is solid. So now the question becomes, which side of this dotted line do we shade? Well, not so easy to tell if it's in standard format because I don't have a y greater than. So all I really have to do is move everything but y to the other side of the equation. So I would have 2y is greater than negative 3x plus 6. Well, I don't really have to go any further, as all I see is that. Okay? Now, this equation over here that I have the circle around, that inequality, rather, is the same inequality as this is. Just because it's algebraically manipulated, it's the same line.
Okay.
Okay? So, I can go through and divide by 2, but do I really need to? Which side of that dotted line do I need to shade?
Above 2y?
Yeah. In other words, because its y is greater than, then I'm looking only at the y-axis, and I want a point that is higher than my line. So any point greater than that, well, there's a point greater than that. That means I'm on this side of that inequality.
Okay.
But it was difficult to see when it was in standard format. I couldn't immediately tell. So you have to at least get the x on the other side and get a positive coefficient y on this side. Now, had I come up with that,
it'd be below.
well, I can't stop. In other words, I do have to divide everything by -2 because dividing by -2 is going to switch the direction. So now it would be y is less than 3/2 x minus 3, which means I need a point less than this line.
Okay.
So you got to be a little careful. In other words, in one case, I was able to stop when I got to this point. I know which side of the line I'm on. But in another case, I have to get it all the way down to y. And it all has to do with, well, one had a positive coefficient, the other has a negative coefficient. That makes all the difference in the world.
Okay. But for the equation, like 3x plus 2y, since it says that's greater than, like...
It's hard to tell what that means. In other words, we don't know which side of this line we're on. At least I didn't immediately. In other words, what if it would have said this? Now it's the other side of the line.
Yeah. Okay.
So looking at it in standard format, you got to at least, if you're dealing with an inequality and you're trying to figure out which side you're on, you have to at least take it down to something that has a y with a positive coefficient and either a greater than or less than sign. I don't care what the rest of this is. In other words, this equation right there is the same as that equation. It's not an equation, it's an inequality, but it's the same inequality. It's this dotted line. Okay?
Alright.
So to know which side I'm on, I got to get it down to y with at least a positive coefficient, everything else on the other side. I don't really care whether that's negative, I don't care whether that's positive, I don't care about any of that. I know that this is the inequality for this line. So I just have to figure out whether y is greater than or equal to this line.
Okay.
Now, if I put an equal sign there, it changes nothing other than it makes that a solid line. All right. You want to do another one like that, or you want to do something different? How'd you do on the 3 equations and 3 variables?
I got no solution on mine. Like, there was only one.
Okay. And it was a no solution, and you got there pretty easily because that
Well,
can be harder to figure out than one that has a solution.
Actually, after I plugged in the first two, there was no solution, so it was pretty easy, but yeah.
Oh, good, good. And you got that right. Well, good for you. I knew it was worth working, spending that time on there.
Yeah. Can you do one of the ones with the inequality or absolute value? Because that was kind of hard to graph.
Sure.
Because that's when you use the V, right, to graph it?
Yeah. It's actually worth knowing what this means. This means 2 things. What does it mean? Well, in fact, let's back up. Let me make it a little easier. What does that mean?
1.
It means 2 different things. What's the first thing it means?
That whatever number's in there is, like, positive.
X is greater than 6 is the first thing it means. Or, whatever's in there, change the direction of the sign and the sign on the number. So that's the 2 things it means.
Okay.
Okay. Well, how does that translate to a graph? Well, there's 6. So x is greater than 6 or x is less than 6. Less than that. Hold on a second. I did that wrong. Back that all up. Well, I mean, back it up to this point here.
Okay.
Let's go through absolute values because this is important for you to know, and I'm not sure you know it fully. So if I had x minus 3 is greater than 6, so what does that mean? What 2 things does that mean?
It means that x minus 3 is greater than 6.
Or
X minus 3 is less than negative 6.
good. And I write it horizontally because I have to solve each of these vertically. Okay? We're used to solving stuff vertically, not horizontally. So these are the 2 things it means, and so let's solve that. What does this mean?
X is equals negative 3. Oh, wait. X equals 2.
X is greater than. How do I solve this inequality?
Do 6 divided by negative 3.
No. Let's go backwards. We have an inequality. It's much like an equation. If I said x minus 3 is equal to 6, how would you solve that?
I think by dividing it.
No. You add. You don't divide. And the reason is because what's going on here? Subtraction.
So you'd add negative or positive 3 to 6 and get x equals 9.
Exactly. Okay? The key is that when you're solving an algebraic equation, and it doesn't really matter if it's an inequality, we got to know how to solve equations. You do the opposite of what is being done. Okay? Right now, 3 is being subtracted, so I have to add. If it was this, what's being done? 3 is multiplying x. Therefore, I have to divide.
Okay.
So you divide only when multiplication is going on. You multiply when division is going on. If I had this, then I would multiply by 3 because it's currently dividing x. If I had this, I would subtract 3 because 3 is currently being added. So you always do the opposite. So I'm going to add 3 to both sides. Or, what's this part?
That one you would add 3 to the right side, so it would be x is less than -3.
Good. So if I graph this on a number line, which is the only place that it makes sense to graph because I don't have a y value, I have strictly x values. Okay, well, it's x is greater than 9. There's 9. Here's -3. So my graph would be open circle, solid going to the right, open circle, solid going to the left. That's how I would graph. The absolute value of x minus 3 is greater than 6.
Okay.
Okay? Notice there's no y anywhere. So now let's talk about doing a y. If I have y equals the absolute value of x, now I have 2 variables, so I'm in the xy plane, not just a number line. And this means that y is equal to x when x is positive, and y is equal to minus x when x is negative. So you get this kind of a thing. In other words, this is the same. Remember piecewise functions? Have we covered piecewise functions?
I don't think, it doesn't sound familiar.
Piecewise function would be y equal x when x is greater than 0 and y equals negative x when x is less than or equal to 0. In other words, you have 2 functions actually. What we're saying is that whenever x is positive, we have y equal x. That's the equation of that line. But whenever x is negative, well, the equation of this line is y equal negative x, the slope of minus 1. So the absolute value function is actually 2 piecewise functions that could be laid out like this.
All right.
Now, if I do something inside the absolute value sign, for example, well, how does that differ from y equal x? In other words, I know that y equal x looks like this. So y equal absolute value of x looks like that.
Then wouldn't you just move it over 2 on the x-axis?
Which way?
To the left. Or no, to the right, because it's positive.
Right, because
absolute value.
X minus h. Always remember that's the fundamental. And so in this case, h is a positive 2, and positive means move it to the right. So if that's 2, then this thing would look like this.
Okay.
This would be y equal absolute value of x minus 2. Now, let's take some other variations on the absolute value. What if I said this.
Then you would go 2 up, and it'd
Correct.
stay on the, it'd stay like
Exactly the same shape. Doesn't become thinner or flatter. It's just a vertical shift because my number is being added outside the function. Notice that the other 2 is inside the function. This number is outside the function. Numbers outside the function are vertical shifts.
How do you know if it's dotted or a straight line?
I dotted this only so I could distinguish it from the one I was drawing. It's always a straight line when it's a function.
Oh, okay.
Okay, the only time it's ever dotted is when it's an inequality. Okay?
Alright.
Only inequalities that don't have the equal sign as part of them result in dotted lines. Now, there's some other stuff you could do to this function. I'm not sure what you want to go over here. What would that look like?
That would be the same exact thing, but reflected.
Over which axis?
The X.
Yes. Make sure you give all of the information. In other words, don't just say shift at 2 units because it makes a big difference whether it's 2 or to the left or to the right. And don't just say reflect over the axis because there's 2 different axes you can reflect over.
Okay.
Reflect over the x-axis or the y-axis. Because it's outside the function, it's a reflection over the x-axis. If I wanted a reflection over the y-axis, I would put it inside the function. And that would be equal to the same thing, right?
Yeah.
Yeah, but we can see that it would be. I mean, if I take this function and reflect it about the y-axis, I don't get anything that looks different. It looks exactly the same. But a reflection about the y-axis happens when you put the negative sign inside the function, not outside.
Will they ever put a number in front of Y?
Well, they could. In other words, if I had that,
So that means you would just start going up 2, right?
no, I would start by dividing both sides by 2.
Okay.
Okay, so I would divide that side by 2 because 2 is multiplying y. I would divide that side by 2. So now what do I have? I have y equals, well, this can be confusing to some people, but it's the same thing as this. You can see that?
Yeah.
A very big step to take in algebra is recognizing this. I can't tell you how many people get stuck there because they don't know what to do with that 2. Well, that just means that the coefficient is 1/2.
Okay.
Now, what's the consequences of that 1/2?
To the right.
No, this now is a multiplier of the function, so it acts as a vertical stretch or flattening.
Oh, so just get like skinnier, basically?
It would get skinnier if it was a number greater than 1. If it's a number between 0 and 1, it gets flatter.
Okay.
That's what that would look like. That's y equals 1/2 absolute value of x. If it was a 2, in other words, if I had y equal 2 absolute value of x, now it gets skinnier.
Okay.
In other words, it would become y because, well, let's look at that. You should always be able to figure this out because it's intuitively obvious. If this equals y equal absolute value of x, well, if I said, well, what if x is 2? Well, I know y is 2, right?
Yeah.
Well, now I'm saying y is equal to 2 times the absolute value of x. Well, now if x is 2, what is y?
Why would it change?
Well, because it's being multiplied by 2.
Okay, then would it be
So y
4?
would be 4, right. So on this graph down here, this first point doesn't come here, it comes up there. And it ends up, the effect is you end up with a skinnier graph. Remember, the graph has to go through all those points.
Okay.
And the key thing to notice here is that this is this one here. This is twice as far away from the x-axis, right?
Yeah.
It's always twice as far away. That when I say y equals 2 times that, that's what I'm saying. I'm saying that no matter what point you plug in for x, y is going to be twice as far away from the x-axis as it was in this function. And that makes it skinnier. In other words, that would be a vertical stretch factor. And you can think of a stretch factor as pulling up on those ends. If this was made of wire or something, you would pull in this direction and you would make it skinnier.
All right.
And the only other thing that we haven't really talked about is what happens if you put the number inside the parentheses. We've talked about all 5 of the 6 things you can do. There's one last thing to do to translate these things. And that is if I put a number inside, like that. Now, because this is next to the x inside the function, the absolute value function, the elementary function, this number now has a horizontal stretch or squeeze factor. The fact that it's greater than 1 means it's a squeeze. It works in the opposite as the vertical stretch factor does. In other words, vertical stretch factors happen when the outside number is greater than 1. Horizontal stretch factors happen when the inside number is less than 1. If I said the absolute value of 2x, like this, that would act as basically the same thing as a vertical stretch. Only notice that it's a horizontal squeeze. In other words, if I push in on those things horizontally, it results in a skinnier graph.
Right.
So always remember that they're opposite.
Okay.
This is called a horizontal squeeze when it's greater than 1. This is called a vertical stretch when it's greater than 1. This is called a horizontal stretch when it's less than 1. This is called a vertical squeeze when it's less than 1. So remember, they're opposite of one another. And now that's all 6 things that you can possibly do to that elementary function, the absolute value function.
Okay.
But the principle is the same no matter what the function is. If the elementary function was y equal x squared, well, I know that y equal the quantity x minus 2 squared is going to be a parabola shifted 2 units to the right of this one.
Okay.
Okay? So these translations apply to all functions, all 10 elementary functions that you've learned. All right. Fortunately, I have a 4:30 that I have to go to, so I hope you don't have any more questions.
No, I think I'm good.
Okay. Let's see. Your mom canceled Thursday's appointment, so are we still meeting again Sunday at 5?
Yeah.
Okay. That'll be the next time I'll talk to you then. I'll talk to you then, Tucker.
All right. Thank you.
You're welcome. Bye-bye.